Hey, I'm Dia, and I am now a stocking cap, with half my face and half my limbs hidden. I have limited my capabilities to effectively express body language. Anyways, this is episode 6 of the series. Though I did say episode 5 was the finale, that was only the finale of the math part. So, what I imply is that throughout future episodes, I will be covering various functions and locate their pseudo-foci using the 5-step rule, which I just called then, that we acquired previously, because if we don't, nobody's gonna care why everything we did all those 5 episodes were important. So this episode, we'll be finding the pseudo-foci of ax³. If that took you 2 minutes to figure it out. I know, and you know, we already did x³ 2 episodes ago. This is for ax³, where a is some variable that stretches x³. Alright, let's begin. Now, let's look at ax³. We can see that the monomial is any stretch factor of x³ that is nailed to the origin. Next, let's look at normal map. And like 2 episodes ago, there are 2 pseudo-foci created from x³, as there are 2 cones formed. Since there are 2 pseudo-foci, then literally, there are 2 separate normal lines from the normal map that cross each PF, as well as the function ax³. Where these normal lines cross ax³ is the solution of the first formula on our 5-step rule. But if you don't remember why that's the case, then that's okay. You may not be at ease of this 5-step rule thing in these earlier episodes, but I am sure you'll get used to knowing why in the future episodes. Alright, to solve this formula, we have to rely on step 1 first. Find f'(x), f'(x), and f'(x). Okay, cool. To get these derivatives, we use the power rule thrice because they're x to the something power. Using that rule, ax³ converts to 3ax², the a remains intact. Next, 3ax² converts to 6ax, and then 6ax converts to 6a. These 3 expressions are the consecutive derivatives of ax³, which we'll be using in step 2. This formula is 3f' f'' squared equals f' times f' squared plus 1. Sorry, I'm used to shorthand notation, so you may hear me instinctively not say the f(x) part. Plugging each function, we get 3 times 3ax² times 6ax² equals 6a times 3ax² squared plus 1. Okay, I forgot to say this on episode 4 and 5, so I'll say this here. Feel free to have a decent supply of paper or surfaces right on for you to solve for x in this equation. I feel like part of the experience is doing the algebra with me, so you'll be like, yeah, that's how I did it, or wait, what? That's not what I got. Where in the world have I done an oopsie doopsie? And of course, it also improves your algebra skills, you know? Okay, moving on. Let's take care of some parentheses. So, the left 6ax² becomes 36a²x², and then the right 3ax² becomes 9a² x4. Next, let's take care of the other parentheses. On the left, these simplify to 324a³ x4. On the right, these factor to 54a³ x4 plus 6a. From what we have now, we can see that we have 2 a³ x4 terms. Combining them like terms, we subtract 324 to 54 to get 270. 270 a³ x4. Next, we have common a variables on both sides, so we end up with 270a² x4 equals 6. Dividing 270 to both sides, the right number becomes 1 over 45. Oh yeah, we also do that for a², so the right becomes 1 over 45a². Okay, to solve for x, we then take the fourth root of both sides to have x only. As a result, the right becomes the fourth root of 1 over 45a squared. Okay, another thing I forgot in episode 4 is to turn this answer into a better looking number. So if you remember your early algebra, the fourth root is also the power of 1/4. And 1 over anything is also anything to the power of -1. So as a result, we have 45a squared to the power of -1/4. Last thing, since we divided by fourth root, our final answer is plus minus 45a squared to the power of -1/4. Now, this guy might be familiar to you. It's that x solution that we got from regular x³. If you remember the purpose of this number, it's, again, get ready, the x value of the normal line that directs us to the pseudo-focus through the components of that parameter. Funny I should say that because we already have the components. It's these guys. The only thing we have to do is change the f's of those equations and then plug the x's, which we just obtained. Now, what I just said is do step 3 and 4 and baby talk. And again, I encourage that you do step 3 and 4 yourself. Alright, step 3. Subbing the f's with what we found earlier, we get x minus the f prime, 3ax squared cubed, plus another f prime, 3ax squared, all over the double prime, 6ax. Expanding the cubed, we get 27a cubed x to the 6th, which is quite big. Now, notice that both numerator terms have some common ax's to cancel. Doing that, we get 27a squared x5 plus 3x. Next up, we divide the 6 to coefficients, where we get 9/2 and 1/2, respectively. Okay, this is a common mistake I frequently skip past to later on look back. So I have these two terms from what previously is a fraction, right? When we subtract a fraction, the subtraction applies to all of the numerator, not just the front term. So one will tend to write minus 9/2 a squared x5 plus 1/2 x, where it should be minus 1/2 x. Now, when I have that out of my system, we then plug the x solutions. Well, actually, no. Remember that plugging those fourth root numbers makes more of a mess than not, so we're going to keep this as it is and find an x4 for us to substitute to cancel the fourth root. And to do that, we factor an x to the entire expression, where we then get x times 1 minus 9/2 a squared x4 minus 1/2. First off, 1 minus 1/2 is 1/2 to take care of that. And now we unsubstitute. Remember that we have a negative root, so we have 9/2 a squared times 1 over 45 a squared. Doing this term, we simplify it to 1/10, where the a squared cancel out. Since this guy is just 1/10, the 1/2 and 1/10 subtract to 2/5. With that, we then unsub the last x, where we get 2/5 times 45a squared to the power of -1/4. And this is the x component of our pseudo-focus. Next, we do step 4. I'll give you a good look at this equation before we start. Alright, deconstructing the f's, we get the f(x) x³ plus f prime 3x squared plus 1 all over the double prime 6ax. Now we do the squared numerator term, which becomes 9a squared x4. Now, this is my style of algebra play. Since dividing the 6ax makes the 9a squared x4 have an x³, we will not substitute it properly. So what I do is multiply the ax³ by 6ax over 6ax to include it in the fractions, so in the numerator it becomes 6a squared x4. Now this term adds to the other big term, which makes them 15a squared x4. With that, we can now unsub the x, where we get 15a squared times 1 over 45a squared, This term simplifies to just 1/3, because the a's cancel. This then adds to 1 where it's 4/3. This divided by the 6, we get 2/9ax. Now, since our x value is on the denominator and has a negative power, this power becomes positive on the numerator. With that, we get 2/9a times 45a squared to the power of 1/4. Now, you may have a more simplified answer where the a gets included inside the root. So for an a outside the root, inside it's a to the 4th in the denominator. In conclusion, our answer would be 2/9 45/a squared to the power of 1/4. Therefore, in conclusion, the answers that we got in step 3 and 4 are the parts of the pseudo-focus's coordinate. Having formed the coordinate of these components, you've already done step 5, where our pseudo-focus is 2/5 45a squared to the power of -1/4, 2/9 45/a squared to the power of 1/4. But there's one thing left. How about the other pseudo-focus from the negative x value, -45a squared to the power of -1/4? Well, remember that on episode 4, our first pseudo-focus was on the first quadrant and the other on the third quadrant? This is because of the odd function behavior of that function, where any point on x³ has an absolute counterpart. The same happens to pseudo-foci, which means that our other pseudo-focus is -2/5 times 45a squared to the power of -1/4 and -2/9 45/a squared to the power of 1/4. In the end, we now have acquired the two pseudo-foci of ax³, and if we plot these points and enable the normal map, we can see that the moving pseudo-focus translates accordingly to the tip of the moving normal map. And so we're done. Okay, before we end, I just have some nagging feeling that someone is going to say that this is just a repeat of episode 4. My answer to that is, yeah, but not totally. My reasons are as follows. Number 1, I'm going somewhere with the a variable. Number 2, I am putting the 5-step rule into action and making you used to it. Number 3, I am trying to make my language clearer and more understandable to the audience, which makes number 4, I'm providing clear explanations to possible I don't get it's from episode 5. With that, I am sorry if episode 5 may have been too mind-smoothing for you. I, likewise, think it's too complicated. And so, that's that for episode 6. Remember, stay safe and have a Merry Creamer. I am Dia in a Santa hat, and I can dance.